Okay, sir. The machine learning. Doka Roach. Session 4. Okay, sir. Tomorrow onwards, we will be coming to the models. Okay. So, first, the steps in machine learning. Oh, sir, your whiteboard is not working properly. Let me use the thing. Steps in machine learning. Step 1, data extractions. Anand team, please take a note, sir. And step 2, data cleansing. Data cleansing and transformations. Data cleansing and transformations. And step 3, data preparations. Step 4, train the model. Step 5, measure accuracy of the model. Please modify this as step 5. And this is as step 6. And step 4, model selection. And step 5 is train the model. Step 6, measure accuracy of the model. Step 7, deploy the model. Step 8, tune the model or rebuild the model. Simply this term is called rebuild the model. Okay. I'm coming to the step 1, sir. Data extractions. Extracting from social media. It depends on the problem, sir. Suppose today one new car is released. What is the comment of people sentiment on the new car model? I want to know. Okay. So the related data is available in. I cannot contact the new car model customers. But a lot of people are about that car or about that mobile model or about that product in social media. People will be talking. Okay. So that extracting data from social media, that is also one of the important skill set will be added to you. Of course, this is data engineering activity, not scientist activity. It can be big data, it can be small data. Volume bigger, big data. Volume bigger, big data. Okay. Volume small, normal data. That's it. There is no special technology like this. Whatever it may be, how to extract it. B, extracting data from databases. That means RDBMS. Extracting data from NoSQL databases. Especially in big data as a OLTP, NoSQL databases will be using. NoSQL means not only SQL. Okay, that means examples: MongoDB or HBase, Cassandra, such kind of things. Extracting data from streaming sources. What are the streaming sources? Sensor data, live cams, live cams. That means here the examples: sensor data, హలో మేడం నేను సెషన్లో ఉన్నానా అయిపోగాలి కాల్ చేస్తాను లేదంటే మీరు ఆన్లైన్లోకి వచ్చేసేయండి యా extracting data from streaming sources, sensor data, and still live cams. Logs, that can be database log or application log or OS log, whatever it may be. Within the from the logs also, lot of information we can extract. Lot of information we can project it. Okay, such kind of things. And extracting data from files. All above are data engineering activities. ETL tools, Hadoop in case of Hadoop, Flume, Kafka, IoT, such things are involved. R language and Python have APIs. R language and Python have APIs for popular social medias. Web crawling is also one of data extraction technique. Python has libraries for web crawling. Online team, are you taking notes, sir? In our language also there are libraries for this purpose, but Python libraries are very good. Okay, so this also comes under data engineering activity. Okay, what is the second step? Data is extracted. Then what you need to do? Data cleansing and transformations. Data cleansing. The major important works here for you. Data deduplication. Duplicated records, sir. Elimination of those the duplicate records is the process of deduplication. And cleaning nulls. So these are another important areas. Cleaning nulls. Okay. Transformations. The input raw data is not always fitted to the model. That means what predictive model you want to apply for that model, the input, whatever the data you have extracted, that is not ready. Understand, sir? Not fitted to the model. Some variables are fit and some other are not fit. We need to transform. We need to transform unfit variables to fit variables. Unfit variables to fit variables. Example, qualification is my variable, sir. How are the qualification values? B.Tech, M.Tech, like this. Okay. Suppose I want to apply linear regression or non-linear regression. What should be your input matrix? All the things should be numbers, right? But here qualification is also one of the important to predict your income. Suppose I want to, based on age, experience and qualification, I want to predict his income. But qualification is also one of the input column. The qualification columns are character values. I will convert into scores. Suppose B.Tech, I will apply the score 6. M.Tech, I will apply the score 8. MBA, I will apply the score 5. PhD, I will apply the score 9. Remaining things as others. Like this, we need to apply some scores. Then only you can apply linear regression. Because your linear regression or non-linear regression kind of things cannot apply on the character variables. All input variables should be numbers, that too continuous. Target variable should be continuous. Understand the point, sir? So such kind of transformations you need to do before train our model, right? Example, qualification to qualification scores. So for this, like btech to btech as 7, mtech as 8, phd as 9, etc. Suppose let's say others as 5. Okay. On such way, we need to perform the transformations. Similarly, one of the input column designation, your income depends on the designation also, right? But designation is also like SE, senior software engineer, doctor, like that. Again, those designations, if I want to apply the some regression model means the input should be number. Those designation also I will be converting into numerous. I will apply some scores. But what score you will be applying based on your domain experience. Understand? If it is software job, I will give BTech, MTech high score. If it is like management related job, I will give for MBA kind of things. For such kind of things, will apply high score. Understand the point, sir? Everything is domain expert based on your in which domain you are working, like that. Okay? Yeah. So on that way, some transformations have to be done, sir. So in this way, so many transformations as our journey goes, as we apply with the models, you will be seeing a lot of things. Next, data preparations. So input data is different. The data, same thing we are going to apply to the train the model is different. We need a train set. The two, you are applying supervised model or unsupervised model, that is also important. What is supervised model? There should be input features and label. That is what supervised. Suppose without label, only input features are there, unsupervised. Okay. On that way, you need to prepare your data. What is our label and what is our input features? Like that, you need to prepare your train set and validation sets and test set. Okay. Now, data preparations of train set, validation set, and test set. And the test sets. If learning model is supervised model, if learning model is supervised learning model, train set should contain or each set should contain input features and label. Input feature means input variables. Label means target variable. If learning model is unsupervised, each set should contain only input features. Each set should contain only input features. right? All of you done? Input features like this. Suggestions for train set. Number one, provide as many as possible input features. As many as possible input, not input features, input examples. Input examples. Each example should contain, depends on supervised or unsupervised. If it is supervised, input features and label. Unsupervised, only features, like that. Okay. That means what is the advantage if I provide more input examples? More patterns will be involved, so that model can learn more patterns. Yeah, write that point. So that model can learn more patterns from the data. Second suggestion, don't keep all data into train set. Example, 80% of train data. What is the purpose I discussed? What is the advantage?
So we can test our accuracy.
In an unknown pattern situation, what is your model behavior? You can test it. Because if I take only 80%, one or two patterns might be missing. These missed patterns can be available in test set. During the testing in an unknown pattern situation, what is the behavior of your model? You can understand. Especially when time comes, like which model to apply, model 1 best or model 2 best, model 3 best. I want to decide which model is behaving well in an unknown pattern situation. That model is very great, very good model to understand such kind of things, right?
So if the
Hmm.
model is trained some five patterns,
Hmm.
how can it recognize other patterns?
Maybe that the unknown pattern can be have some nearest behavior with existed patterns. Understand, sir? Today we are here. That South Africa, Nigeria guys are coming to our Amirpet, with a different pattern. But still, by seeing them, you are saying that he is a man. How? He has more similarities with existed patterns of you. Understand? Like that. Okay? So, don't keep all data into train set. This is one suggestion. 3. Remaining 20% or 30%, whatever it may be, into test set. Again, in a special discussion, we will be discussing about validation sets. Remaining 20% of data into test set. It can be, it's not a rules are 80-20. It can be 75-25 or 70-30. It can be. Okay. The fourth. Okay, sir. The problem is classification problem. First one is suppose which kind of pattern will survive, which kind of pattern patient will dead. I want to know. I want to classify like that. First person survived, second person survived, third person survived, continuous 100% survived. There is a chance of model overfitting. Already I told you one auto example. First auto cheater, second auto cheater, third auto cheater. Then your interpretation is most of auto wallahs are cheaters. But in fact, that is wrong. Understanding these points. That's why don't keep all the data. There is a chance of this one. So that what is another suggestion for that? Shuffle that data. Even if the classification variable is a male and female, continuously males are there, war fitting chance is there. Continuously females are there, war fitting chance are. If I shuffle the data, male, female, male, male, female, female, like this it will come. Then war fitting chance can be avoided. Understand? Yeah. Before train the model, shuffle the train set. Before train the model, shuffle the train set. To reduce war fitting problems. To reduce war fitting problems. Okay. Next, normalize variables. This process simply called as a normalization. Normalize variables. What do you mean by normalize? What do you mean by normalize, sir? That means maintaining equal weightage. Maintaining equal weightage. Suppose I am taking two variables, x to y. Think that x is one share, y is one share. X share price 10 rupees, sir. Y share price 1000 rupees. Second day it became 20, sir. It became 1100, sir. Third day it became 40, sir. It became 1300, sir. In which you will invest, sir? In which company is profitable to invest? X or Y? X is more profitable. I have 1 lakh rupees, sir. How many shares I can purchase of Y? 1 lakh divided by 1000. 100 shares only I can purchase. Same thing. If it is X, 10,000 shares I can purchase. But what happened next day? Doubled, right? Understand why you confused here? Why you confused? The reason one thing is into tens, another one into 10,000s, another one can be into 10,000s. At the time of training, if your data is like this, model will also be confusing like you. Understand, sir? That's why we should maintain equal weightage. Okay. Suppose what is one of the technique? There are a lot of techniques. Normalization. One of the technique I am doing, sir. Among them, one of the fundamental technique. Look at first column, sir. What is the max value? What is the max value? 40. Divide each value by 40, sir. 0 point. Second one also 0 point. Third one also 0 point. Do the same thing for y, sir. What is the max value? 1300. Divide each value by 1300, sir. Everything will be into 0 point, 0 point, 0 point. Now you cannot speak one thing is into tens, another one into thousands. So both are into 0 points only. On that way, you have to leverage their weightages. This process simply called as normalization. About this statement, whatever I said for the fifth point, later by recalling this video, you prepare notes for that. Simply remember the word called normalization. What is a normalization? Normalization is a process of maintaining equal weightage across all the variables which are involving into your transit. Understand the point? So this thing also you have to carry it. Otherwise, model is not a God-given gift. That is also a human made. Definitely, That will also be misunderstanding. Understand the point, sir? Like this. Okay. This is about normalization. All these are the different cares we need to take. All this is pre-processing. And one more important activity here, reduce dimensionality. If input features are thousands, model will be confusing. Model will be confusing. There are some features which are not impacting the target variable. Which are not impacting or less impacting the variable. Which are not impacting or very less impacting the target variable. Even though such kind of variables are not existed, not a problem. Okay? We need to identify such kind of variables. For that, different techniques we have. How to identify whether a variable is hitting the target or not. If hitting, with how much force it is hitting. Understand, sir? Okay? So there are so many techniques. Later we will be learning into reducing dimensionality phase. There are some features which are not impacting or less impacting the target variable. Such variables need to be eliminated from train set and test sets. All these are the different guidelines for your train sets. Observe the first guideline, provide more number of examples. What is the advantage? So that more number of patterns your model can learn. If I provide only 10 examples, there can be one pattern only. If I provide 1 lakh examples, there can be 30 different patterns of the data. That means here pattern means 30 different behaviors can be existed. Next, don't keep all data into train set. What is the advantage of this one?
We can test how accuracy
At the time of testing accuracy, okay, what is your model behavior in an unknown pattern situation? You can understand. Understand, sir. Next, observe the fourth point. Before train the model, shuffle. I'm asking shuffle the data. Because all, suppose you have two class pairs, all continuous 100 records are about first class pair. Again, overfitting chance is there. That's why I shuffle that. Okay, then train it. Next, normalization. What is the problem with normalization? One variable can be in tens, another variable can be in 2 lakhs. There are different normalization techniques are there. Okay, so once you apply the normalization, weightage will be equal. Every value will be into 0 point something like that. So this is one of the best idea. But what normalization technique you need to use later will be learning. So finally, reducing dimensionality. What is the advantage of this process? Unknown variable involvement. More number of dimensions are there, model again will be confusing. Not overfitting. In this case, underfitting will happen. To understand that underfit, to avoid that underfitting, unnecessary variables you just remove it. Understand the point, sir? Okay. Okay. Different techniques again to eliminate, to reduce the dimensionality. In supervised learning, approach different. In unsupervised learning, again, approach is different. Then you need to train the model. But what model you need to train? Then model selection. Before that, which model is best for your data? First, you need to select the model. Once model got selected, then you have to train it. Understand the point, sir? Once it got trained, then test it. Accuracy satisfied, deployed. So up to now in our machine learning steps, how many steps we did? I think the first three. The step one is completely about data extraction, data engineering activities, cleansing and transformations. Then preparations. What kind of preparations we need to do? Like in the next class, I will be dealing, sir. So still, I think the preparation means still some other thing is there, not only this one. If data is unstructured, what to do? Understand, sir? If data is unstructured text, sir, hi, how are you, bye bye. That is what my text. Directly you cannot apply that text to your model, right? At that time, from that text, you need to extract the feature. Okay, such kind of preparations also you need to do. And also, a lot of data can be before all these things. Lot of data can be XML. Okay, how to extract the required entities, required attributes from the XML, required attributes from the JSON data. So such kind of technical work also involving into this one. Observe this one, sir. Up to now, the train of the model is not started. All these things is pre-processing before training the model. Understand? If a DS project is going to take, suppose 1 month time, 20 days time will be killed by this one only. Understand, sir? This is what regular work in your project you need to do. This is what your life cycle. Okay, about remaining steps, tomorrow we will continue the discussion. Right? Yeah, up to now the previous converted videos I will be sharing now only, sir. Just online team, hold on the line. I think today is completed. Hmm. What is the today's conversion, sir? Where it is?